So welcome everybody. It's Sunday night here. I hope it's earlier or a good time for you to be here. Thank you very much for joining us. This is the PriMIA session where we'll give you a sneak peek at our new library for privacy preserving machine learning on medical imaging. I'll start by introducing myself, and my co-hosts will be introducing themselves afterwards. Before we start, a huge thank you to the whole OpenMined team and Rakshit, who is hosting and taking care of all the technical stuff. So thanks a lot for having us. I'm George. I'm a postdoc at the Technical University of Munich and at Imperial College, and I'm a part of the OpenMined research team. I did the presentation yesterday. We will be talking about PriMIA, and I'll give you an overview of it in a second. But first, let my co-hosts introduce themselves. So Alex and Jonathan, you can go on.
Hello, everyone. My name is Alex. I'm a PhD student at the Technical University of Munich. So I started in March, and there was the Corona situation, so I couldn't go to the office in the beginning, and I couldn't start my actual project. So we decided I just do something else, and now this is the project that came out of it. I'm very happy to have it now in a situation where we can present it to the broad audience of OpenMined. And I think it turned out to be very good, and I'm very happy to show it to you tonight.
Hello, everyone. My name is Jonathan. I'm a computer science researcher at Imperial College London, and I also work at Consensus Health, where I focus on privacy preserving machine learning and verifiable computing. I explore things such as trusted execution environments, homomorphic encryption, zero-knowledge proofs, and I've been involved in OpenMined pretty much since the inception, since 2017. And yeah, I've been joining George and Alex on the PriMIA journey and try to bring some of my experience on that. I hope you'll enjoy the seminar as well.
Okay, great. So let me start out actually telling you what PriMIA is and what PriMIA can do. So this is really a very, very big collaborative project between our institutions, and I'm by no means don't want to take credit for any of it. I only organized and wrote a bit of the code. Really, like, the huge amount of work was done by Alex, who essentially designed and wrote all of the code. And it wouldn't obviously have been possible without the expertise of people like Jonathan, and also without the support of all the people from OpenMined, especially Crypto and Federated Learning and PyGrid, who made everything possible. So huge thanks to these guys, and I'll be walking you through the library. So the plan is I'll show you a bit of the code. Show you what the library can do. We'll run a couple of quick examples, and you'll have a lot of time to intervene and ask questions. So if you have questions, my co-presenters will be interrupting me, and we'll be answering these on the fly. So just to orient you.
Just before you start, George, there's
yes.
the Q&A button is at the bottom of your window, and you should be able to ask questions and also vote on other people's question if you want to raise attention to a specific question.
Perfect. So the documentation side for PriMIA is already online. The GitHub repository is still private, but will be going open source very soon. We're aiming for October. And so you'll be all able to clone it and work with it. I'll be showing you the sort of pre-release version in VS Code today. But you can all go to the documentation sites, which you can find here, and perhaps one of the guys can write it also in the chat, so you can have a look. And the docs contain basically everything you need to know for the library. It contains a walkthrough of all of the code. There will be a video walkthrough of the library going online, which we have already recorded. And there's a lot of recipes here for stuff that you want to do, and we'll be covering part of that actually today, setting up environments, and working with the data set which we ship alongside the library, and how to do some of the stuff that PriMIA does. So I'll talk you through that in a second. There's also stuff on configuration and all of the hidden parts that you can do, augmentation and everything, which I'll talk you through, and a contribution guide as well. So let me perhaps get started and give you a brief overview of what PriMIA does. PriMIA is a library for federated learning, securely aggregated federated learning, and for secure inference. And it's specifically designed for imaging and, in particular for medical imaging. That's what it's designed for. The name stands for Privacy Preserving Medical Imaging Analysis. That said, it's all PySIFT, PyGrid, and PyTorch, so it can be adapted to any use case. And if you want to change something, it's very easy to change it. So we chose a sort of an approach driven by a certain use case and by a certain data set, which I'll show you in a second. And that's why we designed the library in that way. But it's very easy to manipulate it, and it was always on, in our mind to enable people to modify the library. I'll talk you briefly through the data set that we used. So this is it's called the Corona Hack chest X-ray data set. And as Alex said, this got started during the Corona crisis. And it consists of chest X-ray images. And I'll show you a few. So let me just switch over to code. Can everyone see the window? Joe or Alex, is everything?
It's perfect.
It's perfect.
Yeah, perfect, great. So this is how the repo looks once you clone it. There's a few folders which are just local and you won't have, but there is a data folder here, and this data folder contains the entirety of this data set that we're shipping, and it's chest X-rays from children. It's about 5,000 images in the training set and about 600 images in the test set. So it's really a big data set you can actually use to do some useful experimentation. And it's a 3-class classification problem. And I'll show you maybe one of the chest X-rays. This is how they look. And there's 5,000 of them, and they're actually provided in the GitHub repository. So when you clone it, you have the data already there, and the whole library is actually prepared so you can use the data directly, and you can just, essentially swap out the data for your own data in this folder once you want to actually do some stuff of your own. You'll also find some other folders. There's a configurations folder. This contains the configurations file, and Alex designed this library so that you can do all of the configuration for the deep learning from one initialization file. So you can set everything you want in here. There's also some files which set the behavior of the PyGrid nodes. So if you're unfamiliar with PyGrid, it's essentially the networking infrastructure for federated learning and the clients. And you can put in the IP addresses and the names for the clients here. The library will read it and it will use it for federated training. So I'll show you how this works in a second. There's some stuff that you won't need to fiddle with. That's docs, figure scripts. This is just stuff for the paper that we are writing. The really important or juicy folders are node. And this is where PyGrid lives. So we have a custom version of PyGrid nodes, which we use. And there's a SIFT folder, which contains our custom version of PySIFT 0.2.9. Then there is a folder called TorchLib, which contains all of the logic. So if you're interested in seeing how PriMIA works under the hood, this is where you should, need to go. You can look at the data loaders, and I'll show you one example of the data loader that we have, which is called a combined loader. And it was made to handle both regular imaging, but also medical imaging formats. So PriMIA is automatically handling DICOM, and you can actually even combine DICOM and regular like JPEGs. So you just throw it in and it'll load it anyway and convert it. All the logic for that is in here in DICOM tools. So if you want to do changes to whatever DICOM loading procedure, you'll find that here. Find config is a script which actually does hyperparameter optimization. So this is included as well. You can run hyperparameter search over the whole federation. And I'll show you an example of this later. All of the models that we provide are in here. These are basically just the usual torch vision models. Let me just close the terminal so you can see. And we have a VGG style model, VGG 16 with batch norm. We have a very simple, small convolutional neural network. If you have like a weak laptop and still want to use the library, you can. And all of the main experiments that we've done, we did with ResNet 18, which is a very nice sort of compact network, which still has quite good performance. So this is the networks that we're using, and you can add models or modify the models in here if you want to. This is just a utility script which runs PyGrid nodes locally, so you can do WebSocket experimentation on your machine, and all of the really like juicy training logic is in here. For example, you'll find the aggregation functions in here. You'll find all of the secure aggregation stuff in here. You'll find PySwift setup code. So this is sort of the big utility module. Moving on, there is 2 environment files, which I'll show you how to use. There's the Conda one, and there is one for pip. So you can use it with pip or with Conda, although we suggest using Conda. And then there's the main scripts for using PriMIA for doing training and inference. One's called aptly train.py, and the other one's called inference.py. And if you use our data and the same data set, you can also use test.py, which is basically just to test if your model is any good, provided that the data is actually exactly the same data that we used. So this is sort of the the high-level overview of the library. One great thing I think that we have is a very large make file. So if you're unfamiliar with make, it's a Unix thing, and PriMIA is only compatible with Linux and macOS. But you can use this to sort of immediately run some commands, and I will be showing you the commands you can use and how they work. So I'll just open up a terminal and show you a few of the features. So the first thing that you will probably want to do is create an environment, and to create an environment you can use this conda YAML file, and you can also use the make file to do it. The command for it is in it. So if you run make install and you have conda on your system, it will create the environment for you. And if we ship updates, you can run make update and it'll update the environment with the new requirements. There's also the opportunity of doing it with pip. You can just run pip install -r requirements and it'll install all of the requirements. So the conda you will have is called torch4p, and you have to activate it. And you'll have the environment up and running, and from there you can run the various commands. So first of all, I'll show you how to work with the data. One of the things you can do is create some sample data folders. So there is this server simulation folder here, and in here there's nothing at the moment. But if you run make symbolic server folders, it will symlink the data and create basically 3 data folders, one for each federated node, and the validation set, which is supposed to be local. You can also run some other makefile commands. You can run make server folders, which will actually copy paste the data to these folders and not just symlink them. So this is if you want to do it on a different computer. And you can also run the command which we will be using today, which is minimal server folders, which will do the same thing, but instead of putting all of the 5,000 images on the workers, it'll only put 4 of them. So this is really good if you want to do like some quick experimentation. And if you want to delete everything and clean up, you can run make clean all, and this will just kill everything. And you can see in the make file what it cleans. It just deleted the folders, and for the rest of this tutorial, we'll be using the minimal server folders, which contain 4 images on each worker, so we can run stuff and it won't take forever. Okay, so once you have your server folders, and these you can do basically, you can do on your own machine if you want to experiment locally using virtual workers. You can also do this if you clone the repository on a cloud machine, for example. You can run PriMIA with this data on there, or you can put in, as I said, your own data and make modifications. And the way to do this, you will find that in the documentation. So we support two scenarios. One is training and the other one is inference. And I'll show you both of these, and I'll also show you the federated hyperparameter optimization. I think these are the most interesting things that you might want to do. So if you want to just use virtual workers, you can use the train.py file, and I'll just show you the help text for that quickly, so you know what the options are. And PriMIA will give you like a nice welcome message. And from there on, you have a variety of options, what you want to do. By default, it'll do federated learning with encrypted aggregation. So if you pass train federated, it will use encrypted aggregation automatically. And if you want to turn it off, you can turn it off with this flag unencrypted aggregation. And you can choose the data directory. So if you give it this server simulation directory, it will just use the workers from there automatically. What you can also do is if you have a really weak machine, you can pass MNIST, and it'll actually download MNIST and split up MNIST in a federated setting, and then it'll train with MNIST. So if you've got a weak machine and you still want to use the library, you can just do data the MNIST. We have Wisdom, which is a library for monitoring training, and there's documentation. You will find it on the site, how to set this up so you can monitor the training procedure. If you train locally without federated learning, you can use CUDA acceleration on Linux only. Mac doesn't support it, of course. And there's also some options for doing resuming, saving, and naming the trainings, and I'll show you exactly where these end up. And you can also use this WebSockets flag, which will look for the configuration file here and will read these IP addresses and set them up for grid node training. And I'll show you that in a second. Okay. So first of all, let's just run a quick local training so you see what happens. You can do this either by running the command yourself. You can also just run the makefile command, which is make federated secure. And if you run this, it'll just it'll show you the configuration, and I'll show you what you need to put in it. It registers the data, does augmentation automatically on the workers. So, and then it starts training, and it gives you, for every epoch, it gives you a really nice comprehensive overview of the training metrics. And now this will train with secure aggregation, and it'll just run some batches. And after that, it'll coordinate and do the next epoch, so we can just run it for one epoch. Are there any questions so far, guys, that we need to answer?
There was just
I don't think so.
About MNIST, but we handled it in the chat, unless you want to expand on that.
Yeah, great. No, I think that's fine. So that was one epoch done, it'll test and it'll go on. So this is basically how training works on virtual workers, and I'll just keyboard interrupt it. So one thing that you will see is that at the beginning of the training, it prints out the configuration. So I'll go into the configuration in a second. It'll also tell you the number of epochs was decreased to 8 because you repeated the data set 5 times, and I'll explain how this works in a minute. The other thing you'll see is this model weights folder here, which will now contain the weights for the first epoch. So you can name it differently. By default, it'll call it federated data server simulation because it's virtual workers, and it'll give it a timestamp and the number of the epoch, and you can just use these for inference later. So this is this model weights folder. And if you run make clean all, this will destroy this folder, so be very careful. Back up your stuff if you want to use it. The other thing is the configs, so we can go briefly into the configurations. And the one we have for all of the examples is pneumonia resonant pre-trained. So I can just give you a brief overview of what the configurations are that you can use. There's stuff about the training in all, like batch size, resolution. There's learning rate decay. There's settings for Adam, because we're using Adam actually on the clients, which is quite new for federated learning. We saw a talk just today talking about this. You can set random seeds. You can use SGD as well if you want. You can use differential privacy if you're using a simple model without batch norm. You can use, or MNIST, you can actually use the PyDP, and it's now called a PACUS, and it'll do differentially private training. You can choose the model if it's pre-trained on ImageNet, if the classes should be weighted by the amount of data on the workers, the kind of pooling you use. Then there's all sorts of settings for augmentation, which you will find in the docs. And there's also some settings here for the federated learning process. So this is quite interesting. There's this sync every n batch parameter, which means during the federated learning procedure, how many batches do we wait on the workers before we do a synchronization and secure aggregation pass. So in this example, each worker trains locally for 3 batches, and then it'll do secure aggregation. And the repetitions data set is how many times the data set will get augmented on the workers. So you have the data augmentation as well. So that's the configuration file. And next, let me show you quickly how the grid nodes work, because you can use these as well. You can use them locally, or you can set them up on the network. So if you are on a cloud machine, or you're in a hospital and you want to run a PriMIA on premises, you just run a Python-m node. And this will give you the options for running PyGrid nodes on the machine that you're on. And these are all the default PyGrid options. So up to here, up to ID, you need to give it a port where it's running, the host IP, the database stuff. And we also have some extra options which are specific to PriMIA. And one is data directory, and this will load the data from that directory and have it ready on the node to be able to train. The configuration file, which is the file I just showed you, which sets how the configuration is done. And since the PyGrid nodes are also used for secure inference, you can also give them a file containing the mean and standard deviation of the data set if you want to do inference on unseen data, so the data can get rescaled. So for doing training on the PyGrid nodes, I'll quickly show you a quick way to do this on your local machine. And that's also in the make file. Oh, sorry about that. Let me make this a bit bigger. Yeah, that's good. So you can run a whole grid node ensemble, which will make a whole group of grid nodes, and you can just run make grid node. And this will start up Alice, Bob, Charlie, and the crypto provider, all on your local machine, and it'll put the data on them. And right now it'll augment the data, and they're ready for training now. So now you need to go on a separate terminal, or you can put the process in the background if you want. And then you can run training on these grid nodes as well by running make federated grid node secure. Oops. And this will do federated learning with secure aggregation using WebSockets and grid nodes. So this will run a bit longer, but it's exactly the same as we saw before. It's just a protocol which takes a little bit longer. And this will work on the open public internet as well. So this is how we trained our final model. I'll just kill this in the interest of time. You can try the same thing out also with, unencrypted aggregation by running federated insecure for virtual workers or grid node insecure for grid nodes. And you can run local training by just running make train local, and it's the same sort of idea. Great. So this is sort of the overview of the training process. Let me now kill these grid nodes here and show you a quick overview of the inference process. So if we go into the inference file and have a look there, we have various options on how to do encrypted inference or unencrypted inference, in fact. The inference script is from the perspective of the data owner. So the idea is, if you write an app using PriMIA, you put the inference script on the client device. And this will take a data directory for data to classify. In this case, I've prepared one here called .inference, which we can use. It wants the model weights, which are the weights of the model, which are created here when you train models. and you can choose to do encrypted or unencrypted inference. And you can also pass it a configuration file for doing inference over the network. And this will read this one, which is the config inference CSV file, which will again take the IP addresses and ports of the data owner, model owner, and crypto provider and use these for inference. If you're local, you can use CUDA, and also there are some issues still with WebSocket, which is not something which is a PriMIA problem. It's the underlying WebSockets library which PySwift uses. We're working on changing this. But if it breaks, you can use pure HTTP or HTTPS. And again, if you want to use a TSL, this is possible, but this is not handled by PriMIA. It's handled directly by PySwift. So if you just want to do a local inference, you can do it encrypted or unencrypted. And these are the settings here in the makefile. I will show you unencrypted now because encrypted takes about 3 minutes. And we're using the FSS, function secret sharing protocol, which is actually very fast. So the old protocol that PySwift used is SecureNN on top of SPDZ, and that takes about 3 to 7 times more. And FSS is actually quite fast. So we've implemented that. So if you run making unencrypted inference, and you have local here, and you can see it running. I've got something wrong, make. Oh, there is no, sorry, there is no unencrypted inference in the local setting. We can just copy paste this though, and it'll run. So if you don't pass encrypted inference, it'll just do it unencrypted. And this takes about 0.4 seconds, and it'll give you back some JSON. So the idea is if you're the data owner and you want to present this in an app, you get back some JSON of the inference results. In this case, I put in a normal chest X-ray, so it classified it correctly as normal here. What you can also do is do the same thing with grid nodes. And if you want to do this locally, you can either go in and do make data owner, crypto provider, and model owner separately, or you can run all of them at once, which is make inference setup. And this will just run all of them at once. So you have the grid node set up on your local machine. They will load the data, load the mean and standard deviation files. So they're ready to run. And again, as before with the training, you can do encrypted inference with WebSockets and with HTTP. I will run the unencrypted version because it otherwise will take quite long. This will run extremely quickly now with the WebSockets. It will only take a few seconds. So it takes 4 seconds on WebSockets, and you can do the same thing over HTTP, and that'll take just a couple of hundreds. This is actually quite fast in this case. I don't know why. This is just something with the protocols, and you can see there's some HTTP information here. Okay, so this is inference, and we can talk about how we do everything under the hood in a second, and we can answer all your questions about this. Before I end the live demo, I'd like to show you the hyperparameter optimization as well. So this is hidden here in torchlib find config. So if we are, if you're on Python torchlib find config.py with a help flag, it will give you some information. You can run hyperparam configuration on the federated setting. I don't know, this is quite rare actually. There's not many libraries which can use this. You can do it on WebSockets over the net. You can give it an amount of trials to use. And we use Optuna, which is the very nice hyperparam optimization library under the hood. And if you pass visualize, it'll open up a server and show you the hyperparameter importances. And you can give it a database file. And you can also do it with unencrypted aggregation. So let's assume I want to do a quick hyperparameter tuning. I will run this now, and it'll give me an error. I'm doing this on purpose, and I will show you why the error comes and what to do against it. If you just give it find config, federated, and num trials 1, it will, oh, wow, never seen that before. Sorry about that. There we go. So this will start running the federated pneumonia here. And it needs a model weights folder. So if you don't have this model weights folder, it's in the, actually in the, you can configure the path. By default, it's configured to put the data set inside the, the database file inside this model weights folder. And if you get an error for this, it will give you a useful error message. So you can set the path correctly to use a different path for the model weights. So this will run, and if it encounters an incompatible configuration or an error, it will just skip it, and it will then put everything in this database folder. And if you've got multiple CPUs, or if you want to run this on multiple systems, you can actually do hyperparameter optimization over several workers just by pointing multiple instances of this script to the same database file. And that will read the ones that it's already done and smartly inform each other. There's a lot of info on Optuna. This is just functionality from Optuna, which you can find in the Optuna docs. Okay, so that's the 30-minute overview of PriMIA. Joe and Alex, please tell me if I've forgotten anything which I need to cover, because I did this on the fly now.
I think you did pretty good in terms of features, and so we've covered a few questions in the while you were talking. And actually, that's a very good question, the one that just popped up. Right now, PriMIA is primarily focused on classification problems, but that's definitely not the end of it. There is I mean, I think we've had in mind to extend it to segmentation, for example, if you're familiar with other computer vision problems.
Yeah, definitely. So this is something that we were very, peculiar about from the start, that we wanted to particularly actually be able to use any PyTorch model. So in this train.py, you'll be able to have a look at all of the logic which is used. But the reality is that there's just this, there's really just this train federated function. And this is like super basic, right? It uses the arguments, a model, the device to put them on, the data loader, optimizer, and some parameters. And for the people who just asked about DP, yes. So we started implementing Torch DP, and there's obviously it's still quite young, the project, and we're talking to the PyDP team as well and the Opacus team to integrate it deeper into the library. So it's certainly going to be a future goal to integrate DP. But in any case, the thing that we do here is just very basic PyTorch. So there's nothing in particular that you could not implement here because it's PriMIA specific, right? These are all simple functions. You send models around, load state dicts. The secure aggregation is implemented entirely in just vanilla PySift with all of the basic functions from within PySift. And if you swap out the model, the data loader and the loss, you would be able to, with relatively little effort, swap it out to any other model theoretically. Okay, any more questions? Segmentation, detection. Yeah, exactly. So these are things we're currently working on. And somebody asked about ARM compatibility, which is a great question. So wherever Python and PyTorch and PySift compile, this will run on. So essentially what Joe said is completely correct. This is just, we are adding no secret sauce. The whole library is based on PySift and PyTorch. The release will be in October, and it's a bit delayed just because we are at the same time writing a paper on the library, which is taking up a lot of our time, and we're ironing out the last bugs and writing all the documentation, and we're having people have a look if everything's all right with them and if everything's, you know, correct and fair and right. And as soon as this happens, we'll release it openly. It'll probably be on the OpenMined GitHub, and you will be able to find it there. Yeah, so this is a very nice question. Does maybe Alex, do you want to answer this, or should I answer?
It was quite funny. We played around a bit with MNIST. And so what we did is that we separated by digits. So one worker had just the digits 1 to 3, the next had 4 to 7, and the third worker had the rest of them. And we saw that it very much impacted the training. So, you know, the training on MNIST is usually very simple. So after one epoch, you have like 99% classification score. And so we trained for 20 epochs and we did not come over 80%. So it's really, really important that the data is distributed equally over the workers somehow. So the more it is unequal, the harder it is to train, obviously.
For sure, and that said, obviously, on the flip side, we have implemented quite a lot of new techniques to actually deal with this non-IID data scenario. So we have a lot of class weighting. We have weighting by content, data content on the workers. We have a lot of essentially augmentation implemented, including mix-up, which helps a lot with non-ID data. So this is really very, very good, it goes very far in counteracting the effects of non-IID data sets. The question by Angelos, if we're collaborating with hospitals, very much yes. In fact, we work at a hospital. Me and Alex actually work for a university hospital. So we have already tested PriMIA on real life clinical data, in fact, 2 different data sets. And oh my God, Patrick, unbelievable. And so we're using it on real clinical data and it works extremely well. And the question of real world deployment, yes, this is planned, but what Patrick said is also true. So we only announced the library yesterday, so we can't have deployed it yet. But we're certainly planning on using it for a use case in oncologic imaging, so that's cancer imaging, probably this or next year, and building it up for this purpose as well. Yes, I mean, it will work with any data. The reality is it'll work with any data. The question is, if you want to do tabular data, do you desperately want to do deep learning using tabular data? Or do you want to use some sort of different model, right? Because if you're going to do linear, or if you're going to do some sort of random forest or whatever, it might be simpler to use just PySift and not necessarily PriMIA, which has a functionality which is aimed at using medical imaging or working with medical imaging. So, but it would work, yeah.
Yeah, I think that's a very important point that you just made, George, and that probably is important to repeat, is that PriMIA really sits on top of PySift. So it's not meant to replace it or in anything. So it is providing you with building blocks to simplify the utilization and implementation of medical imaging problems in a federated learning context, in a privacy preserving machine learning context. So everything you can do with PySift, of course, we can do it with PriMIA, but what you're going to find ultimately in the library are really components that make it easier to deal with healthcare medical imaging data. Typically, all the tricks, the engineering that we've done to make sure it works has vocation eventually to lend back into main PySift, because that could be reused by any library building on top of PySift, not just PriMIA.
Exactly. And yeah, Sue, PriMIA already does some of the work for you. So it checks for the dataset distribution on the nodes. It checks for the data content in the nodes. And we also have some clever tricks with means and standard deviations of the data sets, which get securely aggregated across all of the federation and used to resample the data and, you know, to even out sort of the distribution differences. But the aim of the library is not to do, for example, something like really strong domain adaptation, or to, you know, to really counteract the problems with IAD data. So and this in healthcare is particularly, you know, it's difficult and easy at the same time. It's difficult because it's very complicated data. On the other hand, it's easy because it's sometimes very standardized data. So this is certainly a future direction, but this is, I think, also something we should be looking at, you know, for the field as a whole, not just for PriMIA in our case. Definitely, yeah. So this is why we have so much augmentation going on to try to counteract, you know, stuff like class imbalance. But of course, you know, no, I think no federated learning system will be able to, you know, cope with bad data. If you have terrible data, it's, you know, it's going to be terrible data, and you're not going to be able to salvage it, I guess. Okay. Are there any other questions? If not, I think we can wrap up a bit earlier.
I think maybe one thing we want to mention, I don't think that's in place yet, but we'll probably have an entry point on the OpenMined Slack as well, if you want to reach out and see how you can ask further questions on the library, get involved, all these kind of things. So monitor the announcements now that you've got the URL to the website. Again, the repo will come out and follow very, very shortly.
Perfect. Yeah. So if you want to, I'll answer the question in a second. So if you want to reach out, look for the guys with the PriMIA logo next to their name and ask them. So that's me, Alex, and Jonathan at the moment. There is going to be some interesting announcements regarding healthcare at OpenMined very soon. So for Sue, I can only tease right now. I can't promise. But you know, keep your eyes peeled for what's going to happen in the healthcare sector. I think we have some really great stuff planned at OpenMined, and we'll really need a lot of help for the project that we're planning. So if you're interested in healthcare and medical imaging, like really, you know, keep in touch, and there's going to be a lot of opportunities to work with us. Perfect. Thank you all so much for coming, and thanks to everyone who contributed once more, Alex and Jonathan and the rest of the OpenMined team. Rakshit, thank you for hosting, and thanks all of you guys for joining us.
Thank you, everyone, and talk to you soon about PriMIA and healthcare.
See you on Slack.